This lesson goes with section 11.4 in the algebra textbook. Most of this lesson was designed by a truly amazing pre-student teacher that worked with me a few years ago, and his name was Mr. Dan Etz, so I want to give him credit for all the awesome stuff in here. First, in Moodle, I've linked two videos that illustrate the Pythagorean theorem. One of them is what we call a visual proof. It's an animation that shows you why the Pythagorean theorem is true for all right triangles. And the other is an example that helps you think of what it really means to say that a squared plus b squared equals c squared. If you haven't already done so, you should watch those first. Here's what was going on in one of the videos. We had a triangle in the middle that had side lengths A, B, and C. We built a square off of side A, so that one had area A squared. We built a square off side B, that one had area B squared. And we built a square off side C, that one had area C squared. So before we get down to the real Pythagorean theorem, we need to learn a little bit of vocabulary. First, a right triangle. It's just a triangle that has a right angle in it. It's important to remember that the Pythagorean theorem only works with right triangles. So there has to be a right angle. A triangle can only have one right angle in it. So by definition, we're dealing with triangles with a single right angle. Next, the hypotenuse. The hypotenuse is the side that is opposite from the right angle. And the hypotenuse is always the longest side of our triangle. Sometimes we think of it as the slanty side. In a right triangle, the legs are the sides that come together to form that right angle. It doesn't particularly matter which leg is which. Just know that the legs are the two sides of the triangle that come together to form a right angle. And the word theorem in math doesn't mean like an idea that we think might be true or not. It's not the same thing as theory. A theorem is an idea that has been shown to be true, that has in fact been proven to be true. Why bother with this? Well, right triangles are one of the most useful things to understand in our world. They're tremendously useful in terms of construction because when you incorporate right triangles into structures, it makes them much more sturdy. And they also just happen to occur in a lot of different things that we'll design and use in our lives. So it's a subject worth our time. All right, the Pythagorean theorem. In words, it says that for any right triangle, any triangle that has a right angle in it, the length of one leg squared plus the length of the other leg squared equals the length of the hypotenuse squared. In algebra, we say a squared plus b squared equals c squared, where c is the hypotenuse. It matters that c is the hypotenuse for this formula to work. C can't be one of the legs. C has to be the hypotenuse. And a and b are the legs. So here's a problem that you might come across in your work. I'll give you a triangle, and I'll tell you how long A and B, the two sides, are. And I'll ask you to find out how long C, the hypotenuse, is. So first, we want to write out the Pythagorean theorem. This is an easy theorem to make dinky mistakes with, and so it's a helpful one to show each step of your work to make sure that you don't make those dinky mistakes. So we're going to replace A, the variable A, in this equation with however long side A is, whether it's 5 or 6 or 10 or a half. And we're going to replace B with however long B is. And we're going to square A and square B and add them together to get C squared. Once we've done that, we're going to take whatever we got when we had A squared plus B squared, and we're going to square root it. That'll give us plain old C by itself. This might be easiest to see with an example. So here's an example of a triangle on the left. One leg is 6 units long, and the other leg is 8 units long. And the question is, how long is the hypotenuse? So a squared plus b squared equals c squared. I'm going to call the side with length 6a and the side with length 8b. And c is what I'm trying to find. So 6 squared plus 8 squared equals c squared. Now I do the squaring part. 6 squared is 36. 8 squared is 34, equals c squared. I add 36 and 64 together and I get 100 equals c squared. And then I take the square root of both sides and I get that c has to be 10. So the hypotenuse of this triangle is 10 units long. Please pause this presentation while you do the practice problem on the right, a triangle that has one leg with 2 units long and another leg of 24 units long. Find out how long c, the hypotenuse, is. And remember that c does not need to be a perfect square. You may also come across problems where you know the hypotenuse and one leg, but you're trying to find the other leg. So for example, in the problem at the top here, I have a triangle where one leg is 6 units long, and the hypotenuse is 9 units long, and I don't know how long the other leg is. Well, again here, we can start off by writing out the Pythagorean theorem and plugging in numbers for variables where we know them. We don't know what a is, so a stays as a variable. But b is 6 and c is 9. Another really easy mistake to do when you're doing these kind of problems is to plug the two numbers in for a and b, instead of paying attention to which number replaces which variable in the equation. Just be careful as you work through these. So now I have a squared plus 36 equals 81. I subtract 36 from both sides, and I get a squared equals 81 minus 36. So a is whatever the square root of 81 minus 36 is. 81 minus 36 is 45, and the square root of 45 is approximately 6.7. It's an irrational number, and I've estimated it with its decimal equivalent. So a is approximately 6.7 units long. Now, please pause while you do the problem below to find out the length of leg b that's missing. So here are two problems that I'm asking. Can you find the value of c using the Pythagorean theorem? The first is a triangle that has 4 and 5 as two of the sides and c as the other side. The other is a rectangle where I'm asking you about c. Here's the thing. The Pythagorean theorem is not appropriate to solve either of these problems because it only works for right triangles, triangles that have a right angle in them. Okay, let's pause for a minute to think about if-then statements. If-then statements look something like this. If I could eat a pizza with President Obama, then, and you can imagine all different kinds of things in the blanks, then I would tell him what I think of his policies. Then I would not get garlic on my pizza so my breath wouldn't be bad. Whatever you would say, if you could eat a pizza with President Obama, then you fill in the blank. If I owned a pet rhinoceros, then he would have to live in a really small room. If I owned a pet rhinoceros, then he would be named Joe. You can fill those in. If blank, then I would buy a pair of new sneakers. Maybe if I had $1 million, or if my feet really hurt, or if my old sneakers got eaten by my pet rhinoceros, then I would buy a new pair of sneakers. These are just statements that have two parts of them, two clauses. The first one starts with if, and the second one starts with then. If one thing is true, then another thing follows. An if-then statement says if something happens, then something else will happen. It really is just what it sounds like. The first thing in the examples above, it's eating pizza with President Obama or owning a pet rhinoceros, we typically call P. The something else that follows from it, it's the then I would buy a new pair of sneakers in the last example, we typically call Q. We say if P, then Q. If some one thing happens, then another thing follows from it. We can write the Pythagorean theorem in an if-then form, and here's what it looks like when we do that. If a triangle is a right triangle, so if that first part is true, then a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So if it's a triangle, then this theorem is true. If it's a triangle, then a squared plus b squared equals c squared. Okay, so if a triangle is a right triangle, what property must it have? Well, a squared plus b squared must equal c squared. So it says below, determine if the triangle with given side lengths is a right triangle. So triangle 1, A is 3, B is 5, and C is 7. Let's see if the Pythagorean theorem works for this. So I'm going to write the Pythagorean theorem, a squared plus b squared equals c squared. And I'm going to replace a, b, and c with numbers and see if I get a true statement. Is 3 squared plus 5 squared equal to 7 squared? Well, 3 squared is 9, 5 squared is 25. When I add those together, do I get 49? No, I don't. That means that a triangle with these three sides would not be a right triangle. The Pythagorean theorem doesn't work for it. Please pause this presentation and you use the Pythagorean theorem to determine if triangle number 2 is in fact a right triangle. All right, converse statements. These are different than converse all-stars. Converse has a meaning that's sort of like flip it around, run it backwards. So here's an if-then statement. If Mrs. Dever won the lottery, then she would go to Disney World. So what would we get if we took these two things and switched them? So if we took if Mrs. Dever won the lottery, that's the P, then she goes to Disney. If we switch these two, we get, if she goes to Disney, then Mrs. Dever won the lottery. And this isn't necessarily true. I've gone to Disney before, but I've never won the lottery. We switch P and Q around. That's a converse statement. The converse says, if Q, then P. The converse of an if-then statement is formed when you reverse the hypothesis, that's P, and the conclusion, Q. So the if-then statement is, if Mrs. Dever won the lottery, then she goes to Disney. The converse is, if she goes to Disney, then Mrs. Dever won the lottery. Remember we wrote the Pythagorean theorem in an if-then form. If a triangle is a right triangle, then a squared plus b squared equals c squared. So what do you think the converse of this would be if we switched around the hypothesis and the conclusion? Well, we imagine that it might be something like this. If a squared plus b squared equals c squared, then the triangle is a right triangle. It turns out that the converse of the Pythagorean theorem is true. If a squared plus b squared equals c squared, then it is a right triangle. Now, the converse of the Pythagorean theorem is in fact true, but notice that not all converses are true. Remember the example of me going to Disney. The converse of that statement said, if I go to Disney, then I won the lottery. And I know for sure that that's not true. You're welcome to go check out a couple of sites on YouTube. There are approximately a bazillion things on YouTube explaining the Pythagorean theorem. Some of them are very helpful and some of them are just silly. Here's a couple that you might enjoy. And here's a word problem that we might use the Pythagorean theorem to solve. It says you happen to be standing 15 yards away from the new Catapult 4000 when it launches Mr. Kitty into the air. Mr. Kitty has flown 27 yards when you look up and see him directly above your head. How high off the ground is Mr. Kitty when he flies over your head? This is a Pythagorean theorem problem. We can draw a triangle from Mr. Kitty to you to the catapult, and we can use the information in the problem to label the hypotenuse and one of the legs, and then use the Pythagorean theorem to solve for the length of the other leg, which represents the height of the kitty above your head. This is the end of this presentation. Good luck with your homework.